Hello Year 12 single mathematicians. Just going to go through a question from the mathematical proof revision sheet, which was on page 155. It's the mixed exercise 7, question 23, which asks you to prove that the distance between opposite edges of a regular hexagon of side length √3 is a rational value. So there's a few things which you need to know first. What this term rational value means, and that is another way of saying it could be expressed as a fraction. So in other words, a fraction. Fractions could actually be whole numbers as well, by the way. It doesn't have to be just something like 2/3. It could be 3/1, which would be the whole number 3. So let's draw a sketch to see what they're actually asking us to work out. So draw a regular hexagon, or your best attempt. Every single side length is √3. Now the first thing I do when I draw a regular hexagon actually is visualize that diagonals all intersecting and meeting together in the middle, and every single one of these triangles is an equilateral triangle, because the interior angle of a hexagon, a regular hexagon, is 120 degrees, and when you split that in half you get 60-degree angles everywhere. Now, that might not be useful for this question, but it probably will be. But that's one thing, one property about a hexagon you need to know. Prove that the distance between the opposite edges, so just take a pair of opposite edges, so I'm going to take the bottom and the top. Distance would be this. And apparently that distance is going to be a rational number. So kind of given lots of clues now, and all I'm going to do is focus on that triangle there, that right angle triangle there, which looks like this. 60-degree angle there, right angle. This is half of the distance, I'm just going to call that x. And this was split perfectly in half, bisected with that vertical line I added in, so half of that would be √3/2. And then if you used simple trigonometry to work out the opposite, you would get tan 60 equals x over √3/2. You should know what tan 60 is, but if you don't, your calculator will. So that is √3. And when you multiply by that denominator, you get x is equal to √3 times √3/2, which is 3/2. And then the distance would be that length there is 3/2. By the properties of hexagon, the length below will also be 3/2. So the total distance is 3/2 plus 3/2, which is 3, or 3/1, which is a fraction. Therefore, the distance is rational. End of proof. And that would be it.